we will see how we can augment logic grammar so that we can include features and feature values. So we have seen how grammar can be represented in the form of predicate logic in the earlier sections of this textbook, right? So if we have a sentence like John ate the cat, and what are the premises or things that we require to parse the sentence. So effectively we would need a lexicon, right? So here we have John ate the cat, so John ate cat, the and everything will be written as part of a lexicon, like in this predicate form. Then the sentence itself will be given in predicate form, like what are the positions where the word John occurs, like between 1 and 2, and where does 8 occur, 2 and 3, like that. So effectively what we see here is in case of grammar and sentences expressed in a predicate logic form, right? Even sentence representation and lexicon representation is in predicate form. Okay, and when we come to the grammatical rules, right? The rules are again the form of predicates, right? We have a sentence which is composed of noun phrase and verb phrase, and here P1 P3 indicates positions, right? And it means that if the sentence is starting at P1 and ending at P3, we have a noun phrase spanning from P1 to some point P2, and from after P2 to P3 we have a verb phrase. So like that the grammar also goes on. Then again in order to specify this grammar properly, right, we have syntactic parts, right, like article or like noun, like that. So those syntactic categories are specified again with respect to positional indicators and with respect to the lexicon. So in the lexicon where this syntactic category occur, that is also of importance here. So this is how we generally represent grammar in the form of predicate logic. And suppose that we want to parse the sentence, right? John ate the cat. So what we try is we will effectively give a predicate like yes of 1 5 and check whether such a predicate is possible or whether it is true as per this grammar and as per all these predicates which are supposed to be true. So that is how we parse with respect to logic. Now we are going to see how grammar expressed in the form of logic or predicate logic can be augmented to include features and feature values. So we are first considering with respect to a feature, namely that is number agreement feature or AGR value. So here our focus is on how we can include the number agreement restriction in grammar expressed in logic form. So let's consider this grammar, right? And in this grammar, if you see here, the lexicon is here over here. Okay, we have the words a and two forms of the, right? So a and the are articles, so it is given as is art, and their AGR feature value or the number feature value is also given here, okay, along with the lexicon entry. So this is the first modification that we need to make to represent features in logic grammar. Okay, the lexicon itself is modified. It has it has been modified to add the feature values. Okay, then coming to the syntactic categories, if you see here how syntactic categories are represented, if you see the rule number 2, it is the representation of an article. So again we have introduced a variable number along with the positional indicators I and O. Okay, so if you see the earlier case, right, the syntactic categories, they just had positional indicators, right, and they will also have a variable to indicate that lexical unit which stood for that syntactic category. That's all. They never had a feature here. Okay, so when we are going to include features as part of our logic grammar, what we do is along with this positional notations or along with the lexical unit which stands for that syntactical part, right, we will also include the feature restriction or feature variables. Okay, So here what does this predicate rule mean? This predicate rule means that if there is an article, that is if there is a word between positions I and O, right, and if that word is an article, and it means that it will have a number feature value, and that number feature value will be or should be supplementing or will be equal to the number feature value of the left hand side. Okay, that is a word which occurs between I and O, and if it is an article, right, then what happens is it will be reduced to the left side, or it will be ART between I and O with the number feature value supplied by the lexicon value. Okay, so similarly the other things follow. So let's see that with the help of an example. Let's see the parsing of a clause or a phrase, the dog. Okay, so it is a noun phrase, right, the dog, and if you see here there are three positional indicators, 1, 2 and 3. The occurs between 1 and 2, dog occurs between 2 and 3. Okay, so let's see how this can be parsed with an augmented logic grammar. Okay, so we'll be using this grammar numbered from 1 to 8, and this is our lexicon, right? We have the and dog, and here, as I told you, the lexicon is sorry, this is not the lexicon. This is actually the word or the sentence or the phrase that we are going to parse, right? It is the dog, and its positional indicators are given along with the phrase, along with the predicate. Okay, so our query is given in the form of a predicate again. See, the query is np1 number 3. So what does it mean? It means that we are going to check whether there is a noun phrase in this sentence, okay, between positions 1 and 3, and we are interested in knowing the number feature value. Okay, so it means that if we are able to get a unique number feature value over here, it means the number feature agreement is respected in this entire phrase. Okay, so it actually does two things here when we give such a predicate, that is np1 number 3. The first thing it does is it will check whether there is a noun phrase between the positions 1 and 3, and the second thing it does is, if it is able to return a single number feature value to the variable number, it means the constants the and dog will have the same number feature value or the AGR value. So let's see that how it happens. So we are starting off with np1 number 3, right? So we will take the first production. So we have np on the left, right? So we will use this production, and if you see here, the first argument is 1, second argument is number, and third argument is 3, right? So we will supply 1 to p1, the number is number itself, and 3 is applied to p3. Now we are trying to expand this production, okay, to the right side. So we will see the right side substituted with these values. Okay, so if you see the right side, we have an article part and we have a noun part. So as we have already substituted p1 with 1, again we have article with the first argument as 1, second argument as number, and third argument as another variable p2. Then if we see the noun part, we have the first argument as 2, second argument as the variable number, and third argument is p3, which is by chance 3, or we had already substituted it value 3. Okay, so note that for all the constants on the right, that is article and n, we have the same number feature variable, and which is also followed on the left hand side of this predicate. Okay, so there is an explicit number feature agreement condition posted here. Okay, so this completes the substitution on the first rule. Okay, so what has happened essentially here is, once we did substitution on the left side, we are effectively left with two subparts on the right. Okay, now we need to unify these two subparts and see what will be the values of number p2 and number over here. Okay, so we will see the next thing. As I told you, we are left with two parts, article and number. So let's first proceed with the article part. Okay, article and noun, and let's first proceed with the article part. So as we saw earlier, p1 was 1, number is number itself, and p2 is a variable which we don't know. So the same thing is applied here on the left. Okay, the first argument is 1, second argument is number, and third argument is substituted as p2, then this is exactly followed to the right. So what we have is we have a word predicate, and its I is substituted as 1 and O is substituted as P2. Okay, so we need to first check whether any word exists in location from 1 to P2. Obviously we don't know what it is, so what we can do here is we can search if any word starts at location 1. Okay, so we are searching for that, and we will search it here, right? This is our input. We give the input sentence in the form of predicates, right? So if we check these predicates, we have one predicate where the positional indicator or the positional variable starts at 1 and ends at 2. So it matches our case here because we need something that starts at 1, right? So upon unification of this word with this words, right, or the right hand side with this word representation, what we will get is we will get P2 to be substituted as 2. Okay, and this word variable, right, it will be substituted with the. Okay, so if you observe here, this word variable is shared with the next part, that is ESART. So this the will be substituted in ESART too. Okay, so we have completed the one section of the right side of article, right, where we have found out the value for word, that is the value for P2, which is 2, and we are left with the second part of the right side of article production, which is ESART, right? And what we have to do here is we have to check whether any ESART predicates are there which has the word value equal to the. Okay, so again there is a ESART predicate, right, from our lexicon. So it says that we have the as an article with AGR value 3s. So when we unify these two, what happens is the word already we have it as the, right? Okay, so the remaining variable to be unified is number, so this 3s will be substituted for number. Okay, so this right hand side part is completely over. So this left hand side part actually reduces to I getting the value of 1, number getting the value of 3s, right, and O getting the value of 2. Okay, as we got it from here, right, from 2. So number is 3s and P2 is 2. P2 or O is 2. So that's what we got. So effectively what will happen, it will get substituted on the first section of NP, right? So we have P1 as 1, number as 3s, and P2 as 2. Okay, now we are supposed to move to the next section of the first predicate, that is N2 number 3. So if you consider the case of rule number 6, right, 2 is substituted for I, then number is substituted with number itself, and O is substituted with P3. Okay, now we have to expand the right hand side so that we will finally get what is the number value and what is the value for P3. Okay, so we are going to expand the right side. So the right side is again a predicate word and followed by is noun. Okay, so this word has a variable named word and it shares the variables I and O from the left hand side. So I we will set it as 2 and O is set as P3. Our task is we need to unify it with any other rules that has word as a predicate. Okay, so already we have two rules with word as predicates, right, and we need to check for the rule in which the position starts with 2. Okay, so we have exactly a word that starts at 2, so we will try to unify this word with this word rule. So upon unification, what we will get is we will get the word variables value as dog and P3's value as 3. Okay, and we will use those variable values here also. So we have is noun of dog followed by a number. So we need to again find out the value, what is the value of number, right? So we will check for any is noun predicates with the first variable value being dog. Okay, so we have is noun predicate with first variable value dog, and by chance its number feature value is 3s. So upon unification of 7 with right hand side of 6, what we get is the word value is dog itself and number value is 3s. Okay, so this number value is given to the left hand side after unification. So if we see the left hand side, what we have is we have a noun part or a noun predicate with starting position at 2, the number value at 3s and P3 value as 3. Okay, so this is substituted back to the right hand side of the first production, where what happens in back substitution is the number value is given as 3s and the p3 value is given as 3. So if we consider the number value that we got earlier, right, number value is 3s again for article, and now in this case the number value is 3s for noun. So effectively it means that the article part and noun part of this noun phrase has agreed with respect to number agreement restriction. Okay, so it applies. So what happens is when we reduce it to the left hand side, this number variable of the left hand side or the noun phrase will take up the same value of the variables on the right, and so effectively we have established a number agreement restriction, right, or the phrase the dog follows number agreement restriction. So this is how we will augment normal logic grammar with features, and this is how we will perform a parse. Okay, now consider the case in which we need to record the structure or the way in which a parse proceeds. Okay, or if we need to generate a parse tree, okay, in case of an augmented logic grammar, how is it possible? So actually that addition is pretty easy. So apart from our normal feature variables, we will introduce one more variable, right, that will record how this grammar actually reduces, or this productions of predicates are used to reduce from right to left. So if you see the case of suppose if you see the case of an article, right, in case the rule number 4, just see the rule number 4. This rule number says that article, right, it starts at position I and ends at O, and these are variables, I and O are variables, and it has a number feature. And this article, right, it is a word which occurs in a sentence at any positions I and O. Okay, so what happens here is whenever we get a word, right, whenever suppose that the word that we are after is the the, and its positions are 1 and 2. So as usual, when we convert the sentence into the predicate logic form, okay, we will have forms like this, right? We will have word the from 1 to 2, then dog from 2 to 3, and cried from 3 to 4. So when it is converted to predicate logic form, when we start with this right part, what happens is this the will be unified with word, and the positional arguments will be unified respectively. So when this right side actually gets unified completely with its constituents, what happens is the variable word, right, will be passed to the left side. So what happens is this the will be going here, and it will be marked as an article. Okay, then whichever productions uses article on the right, this article production on the right, it will carry this enclosed the, right, this art the within it as second parameter, and what happens, not second parameter, as third parameter, right? If you see this this article production on the article production or predicate, this article followed by the is the third parameter. So whichever production uses this article production on the right, its third parameter will be this art the, right, and that will be given by this article production to be carried to the left. So if you see this noun phrase, it is composed of an article and a noun, right? So when we get a noun part and when we get this article part, it will be put in the proper places. That is, noun phrase will be composed of article and noun, and here this art stands for art of the. Okay, then again, when this noun phrase occurs as part of any other production on the right, see in this case, in this sentence, what happens is this noun phrase entirely will be taken up, right, within this NP, and it will be substituted in proper place of this S production. So S is composed of an NP, and NP is composed of an article followed by a noun. So if you see here, it is our art the, and art the is one of the parts of NP, and NP is one of the parts of S. Okay, and this is how this parse structure can be captured in predicate logic form, and this is our parse structure, right? That is, the is an article, and the article is part of a noun phrase, and this noun phrase is part of a sentence. So this is how this augmented logic grammar can effectively record structure of a parse.